Hi, this is Elaine. I'm going to talk about Unix, Linux, Mac and Raspberry Pi processes. Programs and processes, daemons, running subshells and background processes. A program is a file that can be run. For example, an application is the text, it's the code, it's a binary that represents a program stored on disk. A process is a program that's running. For example, a shell, thing that you type in your commands into, that's also a process. All processes have unique identifiers. The difference between a process and a daemon process is that this process has started and become disassociated with a user account, its shell, the terminal window, input-output, and is now owned by root, and the parent process is the init process, which is the first one that's run when Unix and Linux and so on start up. So you can use the ps command, different variations depending on the system, but many Linuxes now support all the different types of process command that you could see here. So ps-ax works as well as ps-ef. Just experiment with those. Here's a demonstration. I have a terminal here with my user just logged in, and this one here is my super user. Pretty much the same when it comes to every process, but if you just run ps on its own and ps on its own there, you will see slightly less information because this is logged in using sudo to access super user. Full listings -f. Again, I will do the same in both. You can see that bash is the parent process ID 2075, and ps-f is 3068 with a parent of, sorry, I'm trying to click that one, 2075. So that's the parent process running this. In the case of the super user, you can see that the terminal bash, this is the actual shell that you use to type in commands. The process ID is 2425. So when you type in the command here, that is the parent of it, so it's running in the context of that shell. In this case here, 2423, which is sudo, is the parent of su, and then su is the parent of the shell. You can set priorities for processes, so +19 to -20, where -20 has the highest priority. You can use different commands to view the nice values, including the top command. I'll just give you an example of that. So if you run top, you will see what processes are running on the system right now and the nice values here. ps-l, so you can see the nice value in relation to the current processes in the user's area as well. So you can use the nice command to change those. It is useful to know about these things because when you're running your code, you need to know what context it's running in, what environment it's running in. So quick demonstration of parent-child processes running in a shell. A little bit more on this. I'm going to clear this, Control-C, clear the window, do the same here, tidy things up a little bit, and just show you my own processes running. So I have a C program here that I can run, and that is called test, and I'll show you that quickly. The source code for that is a for loop, each time incrementing I until it gets to this value here when it stops. So this is how it runs, // because if I run test on its own, it will not work because test doesn't exist as a system command. You need to say in the current directory run this. So run test, and that's all it's going to do, increment a counter, Control-C to end that. So that'll run for quite some time. If I do ps-ef grep, pipe the output to the grep tool, which will pull out just my test process, it's not running clearly, but once I start running that, you'll see that it actually comes up. So the parent process for that is 2075, which will be the bash shell that I mentioned earlier. So ps-ef grep, it didn't like me to do two at one time in this case, so So I just have to do it that way, and you can see that bash is the terminal 2075, which is the parent of my process. Now that program's happily running away, consuming a lot of resources, which may not be ideal. So what we want to do is probably kill that command if it's causing problems. It may be that you've written some code that's in an endless loop and you need to get rid of it. And in cases where Control C doesn't work, which is to send the interrupt the process, or to stop the process, which will still leave the process there, but it'll just leave it stopped with Control Z, you might need to kill it. Just be aware that using kill -9 will actually cause problems, because sigkill, which is kill -9, does actually leave a program unable to catch the signal and therefore deal with it. So it could actually leave open files, sockets, special files, temporary files, memory that's still locked, IPC mechanisms left allocated, and so on. So use kill on its own where possible. Quick demonstration of using the kill command. So this process here, I happen to know, is using 3086 as its process ID. So if I say kill 3086, you will see that that process here has now terminated. Okay, so you can also run processes in the background or the foreground. Background processes run concurrently with the shell, so you can use the shell and run the process at the same time. It creates a child shell to deal with the background process. You can't use Control C with background processes, you need to bring them back into the foreground or use the kill command. This is how you run a program in the background. So quickly demonstrate that as well. Let me just clear, I'll keep that all up there, and run test in the background. Now the problem is it will echo all of its output onto the console, so I want to pipe all of the output into, or filter, sorry, not pipe, filter all of the output into this file name here. Now that's what would happen if I just ran it in the foreground. So what I'm going to do is run it in the background, and you'll see I get my prompt back. But just let me get this ready first with ps-ef on both bash. So make sure I've got my bash terminals. So I have my bash terminal there, and make sure I have my test ready to go. So as soon as I've run that, well, you'll see it's not running right now. Let's just prove that. So it's not running. You can see that's just the command I've just run. Now it will be running, and you'll see it's process ID 3108 with a parent of 2075, which is the bash terminal, as can be seen. So that's now running in its own context. Now you can bring that back to the foreground by typing FG, and that's now back in the foreground. Control C. If that doesn't work, as said, we just need to use kill 3108, and so that's fine. So as you could see, there were no processes running with that one. Background processes, that was, and the kill command. Just mentioned bringing things back into the foreground. Now you can redirect the output from a program so that it doesn't go onto the console. You can actually be more specific using std out and std error files, which is inode 1 and 2. Std in is 0, so they're the standard values for files. So instead of what I did earlier, can I just clear this again because it's quite noisy. Text noise. Just clearing those makes it a little bit easier to explain things. So what I'm going to do is run that again, but instead of sending all output to one file, I'm sending standard output to test out and standard error to this file here, and then I will run that in the background, and again we will see if we use the PS that that's running, and 3123 over there, and also you can still carry on and do things in here, and you'll see that this file, let me make that bigger again because it's not very big, you can't see it all. So you'll now see that this file is building up again quite quickly. test. So that's going to show the contents on the screen using the tail command. Let me have a look at that in here. It's quite slow now. This is just a minimal installation. I'm not sure what happened there. I think I'll close that. So that was the tail command. So if I actually ls-l, you can see that file's massive. So let me clear there again and do ps-ef. So when I did Control C, I didn't actually kill the test program, I just killed the tail command, which was telling me what was at the end of the file. Let me kill 3123 before I fill up my system. And there you now should see that process is no longer, and this file is not getting any bigger. Finally, the @ command. That's quite useful to run a command at a certain time. The @ command may need to be installed, so you may need to go and do apt-get-install. Just a quick demonstration of this before I complete the video. So you need to be super user. I'm going to run find out the date and time we are at right now. Let me just clear this again to make it easier to see. So the date and time 13:24. So if I do set the time to 26, at 13 gives me enough time to type it in. 26 today, do this thing. So I'm going to run test, only I need to type it in correctly. I'm going to put the standard output to test out at, just so that you know which file I'm referring to. Test error at, and run it in the background. Control D. Now hopefully I've done that in time. Let's see what time it is now. So I've still got 25 seconds for that to run. So let me see. That shouldn't be running at the moment, and the files should all be, so those other files shouldn't be there. So if I remove test out, just get rid of those for now. Let's clear that screen again, do date, and you'll see that now if I run PS, it will be running as required, and it's running by the @ scheduler. So ls here will show that those files now exist, test out at. So that did actually run the command. You could use a cron job to make that run automatically at a certain time every day. So you put that into your cron, which is a systems administration function that you could also look into, CRON. Okay, so I'm now going to kill that process 3162 because I don't want to be killing my system. And there we are. So you can see that that file was created at the exact time. Okay, so summary. Unix and Linux needs to handle more than one process, so you've just seen that. Daemon processes run in the background with no user terminal, etc. The Apache process is an example of this. You can view process information, top, ps, all the ps commands use man space ps if you're not sure. You can run commands in a subshell as just shown, that it creates a copy of itself to run the process in, leaving your original shell intact. Processes can be run in the background or the foreground. You can set priorities, and you can use the @ command. Quick summary of those commands. So ps in this form, nice to set a nice command or renice, top, the top command, signals, so you can use the kill command to kill a process as here. Again, more examples here to kill processes and the foreground command and the background command to run processes in the foreground and background, and redirecting your data. You could also experiment with stopping the terminal output, although this is different on different systems, so you might want to experiment with that as well. Do man stty, and then you have the at command. One thing I didn't show you was the atq, but that just gives you a list of jobs that are in the queue. So atq, or at space minus l list of jobs, and you can remove them using at minus r with the job number. That's something you can experiment with once you get using the scheduler. So thank you for watching and good luck experimenting.